Here on Earth there are three major states of matter: solid, liquid, and gas. Now I know there's a fourth state of matter called plasma, and it can really only be found in a couple places here on Earth, so we're going to skip that for now. Here's a self-check list. These are the things that you're going to be able to do by the time you finish watching this video. You'll be able to describe the movement and the speed and the energy and the distance between atoms. You're going to be able to indicate whether they have specific volumes and specific shapes. You'll also be able to explain the major gas laws. Now by the time you've reached middle school, you are probably pretty aware what the difference is between a solid, a liquid, and a gas. But now we're going to start talking about the atoms in those particles, or in those phases of matter, sorry. In solids, the particles, or the atoms, are tightly packed together, and they don't move past each other. That's not to say they don't move at all. They actually will vibrate in place, or they'll shiver, or they'll shake, but they can't move past each other. That's what makes something solid. Now solids have a definite volume and a definite shape. Those two things can be measured if you were given the right equipment. Some silly examples of solids, in case you've forgotten, would be your clothing, school bus, your car, street signs, ice. Even though ice is coated with a layer of water on the outside, it is still frozen solid right there in the middle. Now in liquids, particles are still tightly packed together. They're still pretty close, but they can slide and move past each other. They can slip around each other and squeeze around each other, and that's what makes liquids easy to pour. Now they have a definite volume. You can measure it using a cylinder, but they don't have a definite shape. And you can prove that by pouring water into different containers. Every time you pour it into another container, it's going to take the shape of that container. Here are your examples for liquids. You've got milk, juice, melted chocolate, the ocean, soda pop, gasoline, anything that has those tightly packed particles and that can be poured. Now I know some things that are made of grains can be poured, things like sand or salt, but we're talking about liquids, things that are so tightly packed together that they'll change shape with their container and that they'll flow easily. This is where things start to really change. Gases are not tightly packed together. They're actually really far apart, and they have so much energy that they will slip past each other very quickly. Sometimes they'll collide with each other and bump into each other. But they're far apart, they're quick moving, they have a lot of energy. You probably already know examples of these too. These examples of gases on the screen are oxygen, a helium tank, smoke, pollution, wind, water vapor, things like that. Now gases can do some really funny things. There are actually two laws about gases that we'll cover just briefly. The first one's called Charles' law. This is a law that describes the relationship between a volume of a gas and temperature. When the temperature goes up, the volume will go up. When the temperature goes down, the volume will go down. One of my favorite examples of Charles' law is a hot air balloon. Now the air is always there, it's always around us, but what happens is hot air balloons are equipped with a big tank of gas that you can light. So you've got this heat source, this fire source. And as you heat the gas inside the balloon, the gas starts to expand and get bigger. And just to simplify things, let's pretend like there are only 7 molecules inside a hot air balloon. There on the left, you can see they're closer together, and as you heat the gas, you can see on the right that those 7 molecules move farther apart. The second law that we're going to talk about is Boyles' law. Boyles' law is also about the volume of a gas, but this time we're going to relate it to pressure. So when the pressure around a gas goes up, the volume of the gas goes down. So this is the opposite of what we just talked about. And when the pressure goes down, the volume goes up. One of the best examples of Boyle's law that I could find is scuba diving bubbles. Now if you look right there at the picture on the left, you can see some scuba bubbles. The lower they are, that means the deeper the person is in the water. So the lower bubbles, the bubbles at the bottom of the picture, have actually a little bit more pressure on them than the bubble at the very top you see there. So as the bubbles rise to the surface of the ocean, they'll actually expand and get bigger because the pressure is decreasing. Now the deeper you go in the ocean, the smaller your bubbles would actually be. The man on the right side of the screen is demonstrating this same thing with kind of a cool bubble that he's learned to blow there at the bottom. So as those bubbles float to the surface, they actually expand and get bigger in volume. Now those two laws show us that volume of a gas can be changed. There are things you can do to change volume of a gas. So there is definitely not a certain shape or volume of gases. And here we are at the end. The last thing you need to understand is that the state or the phase of matter can be changed for objects, but it all depends on energy. So if you add energy to a substance and speed up the particles, you're going to change the phase of matter. And if you remove energy or slow the particles down, you're going to change the state of matter again. This little table shows you what I'm talking about. If you add energy to something, and a lot of times that's just going to be in the form of heating it, if you do that, you are going to change a solid to a liquid, or a liquid to a gas. You can think about it like having a chocolate candy bar in your pocket. If you have that in your pocket and you walk around all day and you sit down, what's going to happen is you're going to add energy to the solid chocolate bar and you're going to liquefy it. The chocolate will take on your energy and it will change states. Now if you remove energy or cool something, you're going to go the opposite direction. So if we take a liquid like water and we start to cool that down, like say in the freezer, we'll be able to turn the liquid into solid ice. Here's that self-checklist one more time. Hopefully now you can describe the movement of atoms in each state of matter. You can describe the speed and the energy of the atoms in each state. You can explain the distance between the atoms and how it relates to the state of matter. Hopefully you can indicate whether or not each state of matter has a definite shape or volume. And you'll be able to explain how the volume of a gas is altered by changing pressure or temperature. Now if you said no to any one of those 7 things, you need to start the video over and double check because the answers to all of those are found in this video.